Salutations to you out there. You are welcome back. We have another question to solve today. And the question we are going to solve today is under the application of laws of indices through theory of logarithm. We are giving this question on the board and we want a solution to this particular question. For us to solve this question right now, we are going to apply some laws, some rules of indices. Now let's go solving the question. If you look at this question, the first thing we are going to do here is this. I have 49 here, I have 5 and 10 here. So the first thing I will do is that if we observe that these two are already simplified, but this 49, we are going to simplify it further. As in 49 is equal to 7 times 7. That means I can say that my 49 is 7 raised to power 2. Then another thing we need to put into consideration is that here we have a power, but the base is not given. And whenever the base is not given, we are to assume that the base is 10. So here now, there must be a base there, and the base is 10. So let's go solve the question. We are going to have 49 is 7 raised to power 2. So we have 7 raised to power 2 log 7 x minus 1. Then I have minus 5 log 5 3x. And I have plus 10 log 10 5. The next law that we are going to observe is that if I have something of this nature, log a, then I have b raised to power n. This b will come to this side. That means I will have n log a b. Then I can reverse this process. So what I'm trying to say is that this two that is at the back now will come to the front now. It will now serve as the power of this. So if you do that, you will have 7 log 7 x minus 1 square. You can see the 2 is now a power. Then minus 5 log 5 3x 3x, then plus log, then plus 10 log 10 5. Where do we go from here? There is a certain law of indices, law of logarithm. We have something like this: a raised to power log ax. When you have something of this nature, you observe that this a is a base here, and we have the whole of this as power. But if you check this a and x, you observe that this a is also a base. Law of indices, this one will cancel, and the answer here now will be equal to x. What I'm trying to say is that this 7 and this 7 will cancel. We are going to have x minus 1 square left. The same thing will happen here, minus 3x, and the same thing will happen here. We have plus 5. Then we can now equate everything to 0. So I have is equal to 0. So the next thing we have, we can now see that we have a quadratic equation now, of which we can expand and factorize further. That means we are going to have here, let's simplify this. We have x square minus 2x plus 1 when you simplify this. And we have minus 3x plus 5 is now equal to 0. And we can now simplify this further. So let's bring the terms together. We have x squared minus 2x minus 3x plus 1 plus 5 is equal to 0. And that will give us x squared minus 5x plus 6 is now equal to 0. So we now have a quadratic equation, of which we can actually use factorization method to simplify further. We are going to use factorization because it is one of the shortest methods of solving a quadratic equation. I have 6 here. I can use 2 and 3. But minus will be here, minus will be here. That means I will replace this with the 2 numbers there. So I will have x squared minus 2x minus 3x plus 6 is equal to 0. I can now pair them together. If I should pair, I will have x into x minus 2, then minus 3 into x minus 2 is equal to 0. So from there, I can now collect like that. You can see I have what something that is common in the bracket. I have here x minus 2, and I have here x minus 3 is equal to 0. So I can now equate both brackets to 0, or x minus 3 is equal to 0. So my x now will now be equal to, this one we come here, we have 2, or x is equal to 3. Now, to be rest assured that we are correct, you can actually do this on your own. Substitute the value of this x, 2 and 3, into this equation. It must be equal to 0. Thank you for watching. God bless you.